Hello friends. So today we will be using DWSIM to simulate a conversion reactor. The reaction which we will be simulating is carbon monoxide reacting with hydrogen to give methanol. Both carbon monoxide and hydrogen are in gas form. Then package which we will be using is the Raoult's law. The inlet stream is given as mass flow which will be coming in is 1500 kilogram per hour at pressure 70 bar 320 degrees Celsius temperature, and the respective mole fractions are given. The reactor type which we are assuming is isothermal reactor, wherein the temperature is assumed to be constant throughout the reactor. Important thing about today's reaction which we are seeing, it is a conversion reaction, which means the conversion of our base component, which is carbon monoxide, is given, which is a function of temperature. You can see the conversion of XCO, that is mole fraction of carbon monoxide, is given by 267.45 minus 0.591 into T. T is temperature in degree Celsius. Please remember that. Now let's move to our interface of DWSIM, where we will be simulating this reaction. So friends, we are on the interface of DWSIM. So let me go to the file. I'm selecting new steady state simulation. A window will open. I will click next to select my components. The first one is carbon monoxide. So I'm just typing the carbon monoxide to search, and you can see it appears here, and I will just click on this. Similarly, I will be selecting hydrogen and methanol as well. So hydrogen is selected, and lastly the methanol. I will click next so that we can select our property package now. So as I said, our property package is Raoult's law. So you can see here Raoult's law. I will double click, press next, and system of units, as you know, we are selecting C5. In even in last two lectures we have done the same thing. So C5 I am selecting here as well. I'll click on finish. Let me maximize this window. I will click on material stream, which is given on bottom side here. So let me just configure this material stream by double clicking on this. Here I will change the name to feed stream and press enter. In flash spec, it is temperature and pressure by default. So temperature, as we said, was so let me just check what was the temperature. Yeah, so it's 320 degrees Celsius. 320 degrees Celsius. Then pressure is 70 bar, and mass flow is 1500. So I am just inputting all that and pressing enter. Then I will select compound amounts. Here I will have to select mole fraction. It should be by default. If not, you have to select it. So mole fraction, as I said, carbon monoxide is zero point 0.2, hydrogen is zero point 0.8, and methanol is 0. I will click on accept changes. So my feed stream is configured here. Now let me just configure my reaction. I'm going to edit, and I will click simulation settings, where I will go to reactions on the top bar. In reaction, I have a chemical reactions column. I will click on add reactions. Then I will have to click on the conversion reaction. As I said, we are looking into a conversion reaction this time. The description is nothing but methanol. Then the name is methanol. The description you can write conversion reaction of carbon monoxide and hydrogen to form methanol. On in bottom I have different columns. So I have an include column under which I will have to select all the boxes. The base component here is carbon monoxide. So I will click on that. I will have to select stoichiometric coefficient. So a single carbon monoxide when consumed, that's why I'm writing -1, reacting with 2 moles of hydrogen. So I'm writing -2, which gives 1 mole of methanol. So I'm writing +1. So as soon as I click on balance, so it will give me here OK. This means my reaction is configured properly as far as stoichiometry is concerned. Then my base component is carbon monoxide and phase I will have to change it to vapor. So in conversion we will have to type our function which was given to us. So there are two ways here. You can either write the conversion. For example, if you know it is 40% conversion, you can just write 40 and leave it. But since we have an equation given, I will type that. So 267.45 minus 0.591 into, so so T was given in degree Celsius, and here you can see it is in Kelvin. So I will just change T into Kelvin. So that is T minus 273, bracket close. I will click OK and I will close this window. So my reaction is also configured. Now let me put the reactor. So I will click on reactors. So you have a conversion reactor. I will put a conversion reactor here. Then I need two streams. This is 1 and 2. One is for vapor and other is for liquid, because since you can see in a conversion reactor there are two outputs. One is top one, which is a vapor phase, and one is bottom one, which is a liquid phase, and one energy stream I will give. Now let me just rename this. This is nothing but vapor phase, vapor product, and this one is my liquid, so liquid product, and this is the energy stream. So I will write as energy. Now it's time to configure our reactor. So I am clicking on reactor. You can see the window opens. So the inlet stream I will select feed. Outlet 1 is vapor product and outlet 2 is liquid, and energy is energy. Um, Please make sure that you select isothermic here, because as I said that our reactor is isothermic. Raoult's law is selected by pressure by default. Then flash algorithm is by default. So these are the flash algorithms which we can select. So there are different flash algorithms. Here it is nested loop VLE1, which is standard. Now our reaction and our reactor and our inlet feed stream is configured already. So I am clicking solve flowsheet on top, after which I will get my result in the result column. Our results are ready. On the bottom you can see in result general, then reaction, you can see the conversion of methanol, how much methanol is formed. Then you can see conversion. So carbon monoxide is 78%, hydrogen is 39%. On top of that you can go to top bar, click insert, click on master property table, So a window will appear on this where double click to edit is written on this. Just double click and you will see different properties which actually you can get in table form. That is the best feature of this particular software. I'm clicking on feed, vapor product and liquid product. I will select temperature, pressure, mass flow, molar flow. Even I can check individual flow rates as well. For example, here I can select mass fraction mixture of carbon monoxide and molar fraction mixture of carbon monoxide. Similarly, I will select for hydrogen molar fraction mixture and mass fraction mixture of hydrogen, and lastly for methanol, mass fraction mixture for methanol and molar fraction. And I will close this window. You can see a very good property table appears on this. You can see different parameters are given in the table as you select. So you can select different parameters and see how they are changing. Another interesting observation is in liquid product, you will see 0 everywhere because there is no liquid produced. This means, so in similar way, this can be done in DWSIM using property simulations. So this was a conversion reactor which we saw. So if you liked the video, please kindly like, share and subscribe. We'll be discussing many more different kind of reactions and even different kind of softwares, not just in chemical side but also in different subjects like data science, etc., and the softwares associated with that. But your like, share and subscribe is very important for me because this will encourage me to produce more and more such interesting videos. Thank you.